welcome back to another video where today we are going to be playing Universe Sandbox 2. Now, the reason it might look a little weird on you guys is because it's in Windows mode and my computer doesn't want to take it out of window mode, so I don't know why. But I have played this game before, and the reason I didn't have it anymore is because it completely messed up because I had such a terrible computer at the time. I have a better computer now, but I had such a terrible computer at the time. It just completely gave up and put all the textures as the skybox. So yeah, they were everywhere. So anyways, but I have a better computer and I figured I'd play the game, test it out. And so this is Earth here. This is moving very fast. You can see that is actually so as you can see, this is about like a second. It's very slow, and it's kind of cool. Look at the other side, all these city lights. You can see it over here, the peaks. We'll speed it up a little bit. So I want to get the US here. Okay, so let's see. Looks like New York up here is very light. Florida is very light. It's almost Florida. So these key peak cities. That's interesting. Anyways, that is Earth. And yeah, so if you guys don't know about this game, yeah, you can pretty much just mess with stuff. It's awesome. It's like the best game ever. Alright, focus on the sun. Focus on the sun. Oh, stop. Let's go away. This is like there we go. Okay, finally. So yeah, we can change stuff like this before. So we can edit here. You know, do stuff like that. We can add. Objects. We got tools. We can explode, fireworks. Fireworks, pow, pow. So as you can see, you got fireworks exploding into a nice colorful explosion there. As you can see, they're quickly scattering. Wow, that is nice. You can change the material of it. It's pretty neat. You can collide it with stuff. You know, this is simulation. Here's we get a chart, and you can see all different sizes. The sun is obviously the biggest in here, and then we have this, which is the timer. Then this is to advance time. We're at 2043 right now. Man, I just realized what a thing that is happening over there. Right, so let's click on the sun here. We should, yeah, okay, so we can go in here and edit all this stuff. We can change the speed, we can change the appearance, we can change how old it is, because as you can see, if we make it 10, doesn't, if we were to make it, 10,000? It's fairly good, but if we were to make it like, it's a, oh, but I don't know what to put it for. You can make the surface gravity way high, you can make the temperature way higher, like that high, and then it's ultimately going to change, and that's very hot. You can obviously change the appearance and stuff. Motion, here, how fast it's doing that, rotation, all of this stuff, you can't change all of it, but we can change what it's made out of, we can make it made out of more iron, we can make it more out of make it mostly out of water, make it out of hydrogen, there's a bunch of different stuff we can do. We can delete it, we can, we can just do all this stuff, and it's actually pretty cool, what we can do with it, and yeah, it's just also awesome. So we can go over to Mercury here, and we can make the mass way higher. So if we were to change this to Milky Way here and make this, we'll just put it at that. Boom! Mercury is now a black hole and has eaten everything. Let's get another simulation out. So we're going to open the existing simulation. We're gonna see the Parker Solar Probe. It's actually a good one considering what it is. So where is this at? The Parker Solar Probe is right here as of right now. We can scroll in and maybe get close enough to see it. Alright, so it's a little hard to see, but there you go. And this is what it looks like. I've actually never seen it, but I am doing a project on it in science. And we drew a picture of it, and this is the picture that we drew was nothing like it, because no one had seen what the picture looked like before. But now I have seen it. We'll scroll out here, and as you can see, because this is very fast, but it's going to head this way. I don't know where exactly this is at. This is today, actually, so it's right around here-ish, as of today, and, as you can see, towards the end of this month, start closing in on the sun, and you can watch the dates count up right down there, and see it slowly coming in, and it should make a sharp turn, if that's how this is gonna go. Maybe not, I don't know, but as you can see, by next month, by the 20th, it's gonna kind of curve off here. So this is going to be its main peak here, it looks like. And then, I guess it's just going to be gone. Which is a little sad, honestly, but, it's going to help us a lot. Definitely going to help us a lot. And then looks like, yeah, so it launched here. And by looks like almost the end of this year, it'll be back curving into our orbit. It looks like by the 12th or 13ish, in between there. It's gonna be pretty much back where it started of next year. So doesn't actually take long for this, if you think about it, to go, but it's there, you know. Looks like you might just sit here. Yeah, I'm doing a project on this. I should probably be learning about this. It's pretty neat. I wonder, actually, if we were to speed this up, it looks like it's gonna head back towards the sun once again, and maybe stay in an oval shape. Looks like it's going to eventually start heading down. So it is going to circle back around, and I know this is probably dizzying for you guys. Okay, slow down. So it looks like by around 2040, it's going to have settled almost directly into Mercury's orbit, which has, if you noticed by this, the sun is actually heading that way, which means that we're moving. And if you think about it, our solar, so you're here, and then you got Mercury, Parker Solar, Venus, Earth, Mars, and then once you get from Mars, you know, you're way out here, and then you got Jupiter, then you got Saturn, then you're even further with Uranus, and then Neptune is there, which is like really far apart. Let's see, Jupiter's moons, ultimate engineered solar system. Don't know what this is, but it looked interesting. Oh, this is not very good for my computer. Alright, how many planets can you cram into the habitable zone of a star and still have a stable system? Astronomer Sean Raymond has been exploring this question on his blog. He found that you can fit 8 rings of the 52 planets into each habitable zone of the Earth. Its planets is just half the mass of the Earth. There's 416 planets in the habitable zone on orbits that are completely stable. This trick is to alternate between the prograde and retrograde orbits. In other words, each ring of planets orbits the sun in the opposite direction as its adjacent rings. However, just because this is a stable configuration for a planetary system doesn't mean it's likely to exist. It's unclear whether it would be possible for a system like this to exist or form naturally. That's why Sean Raymond calls this the ultimate engineered solar system. So it's pretty neat. So as you can see here, this is the uninhabitable zone. It's where it's getting too hot, and then you got all this room for the habitable zone, which, as you can see, 416 different planets are in here. And it looks like, did he really name them all? Holy moly, they're all named. Okay, that must have taken a while. Notice my frame rate drop. But anyways, this is where it starts getting too cold, and then out of that, it's the vast openness of space. So, Parker Solar Probe closest to the sun is going to be right here around 2024. It's going to be the closest it's ever going to get to the sun. And wow, 2024 is on August 12th, 2018, NASA launched the Parker Solar Probe, a spacecraft designed to study the sun's corona. The probe is named after astrophysicist Uriah Parker, who first coined the term solar wind to describe the flow of energetic particles from the corona. It carries instruments to measure these particles and the sun's electromagnetic field. Over the course of its 7-year mission, the Parker Solar Probe will orbit the sun 24 times. It will pass closely to the planet Venus 7 times, and receiving great gravity assist that will shrink the spacecraft craft's orbit, allowing it to get closer to the sun with each pass. After the 7th Venus flyby, the probe will be in an orbit, allowing it to pass within 8.86 solar radii of the sun. More than 7 times closer to any previous spacecraft, as shown in this simulation. The first of these close solar approaches will occur on December 24th, 2024. So it's pretty cool. Go check that out. I'll probably have a link in the description. If I don't, I forgot about it. So remind me in the comments to put it in the description, and then I will fix that if it's not already in the description. It may already be in the description. I have no clue. So, it may or may not be there. I have no clue, but I will try to remember. But anyways, let's get going. So that is pretty cool, especially because I'm doing a project about that in science. So let us see the ultimate engineered solar system. Looks like that's already happened. Evidence for a 9th planet. Now, I do remember something about this, but I didn't read too much up on it. We'll see. It looks pretty hefty. Is my frame rate about to drop? We'll read what it says here. If I'll ever load. It dropped a little bit. The discovery of a hypothetical 9th planet in our solar system was announced on January 20, 2016 by researchers at the California Institute of Technology. This came after years of research into explaining the particular but very similar objects, but very similar orbits of 6 small bodies orbiting beyond Neptune. There's only 1 in 15,000 chance that clustering of the orbits shown on the left, away from planet 9, is coincidental. In mathematical models, the researchers have shown that another more likely expedition for these 6 highly orbits is a gravitational influence on the 9th planet. The 9th planet is hypothetical, which means that it has not been directly observed yet by telescopes. But researchers say there is a very good chance of spotting it in the next 5 years if it does exist. So, as you can see here, we got all these different ones, and then here's the supposed planet 9. It's gonna be way out here. You can see. We'll take a look at what supposedly it looks like. Yeah, it looks like they just put a dark texture for it, but that is what the planet 9 will be. And if we do find it, see, here's Neptune. Now that's just gonna give you a thing, because remember we talked about it. Neptune was really far out. Remember on the other scale, planet 9 is that far away. I don't even know if that's close enough to be pulled in by the sun. Especially because you can see these, if we'll speed up, I don't know if they'll turn around. Looks like it, yeah, look, did you just see those 3? Alright, here, we'll slow it back down. Stop it. Look, do you see these 3? They just shot off. This one looks like he's making orbit, but still. For this one to be way out here, it just doesn't seem possible to be in orbit. So, but like I said, we may or may not see that. Here's the eclipse, by the way. It's gonna occur right around here-ish, and as you can see, there is it was pretty cool. We got here 98% darkness or something, and it's actually kind of cool how that was, because I didn't go to school that day, and for how much darkness it actually was, it wasn't as dark in other places, because some places with 100% darkness, yeah, I'm just gonna keep saying darkness, it was like dark. It was like night for them, but with us, with the 98%, we're here in Arkansas, but with the 98% darkness. It it was darker, but I don't know. If I was sitting in school, I probably would notice it'd probably just be, a cloud coming over, but like a hazy cloud. It was really weird, but I'll read something about it here. The solar, which you probably already know, it was last year. But anyways, the solar eclipse occurs when the moon passes between the sun and the earth, and are partially or fully blocks the disk of the sun. When it completely blocks the sun, it's a total solar eclipse. A solar eclipse. Rare events happening once about every 18 months, but the opportunity to view them is even more rare. There's only a very narrow path across the Earth from which they can be viewed. On August 21st, 2017, the continental United States witnessed the first total solar eclipse in 38 years. Parts of 14 different states, from Lincoln City, Oregon, to Charleston, South Carolina, went dark as the moon's shadow passed over them. So that is pretty cool. If you think about it, you probably are like, every 18 months, all this space on Earth, where's this going? Well, do you see this giant here? This giant ocean. So that's the Indian Ocean. But anyways, it's the Pacific. Pacific and Atlantic are the biggest oceans, and they are massive. The Pacific alone is probably bigger than it's definitely bigger than the Atlantic, but it is just a massive, with all this space right here, and then little but with all this space, it just doesn't come anywhere close to land. It's just, so it's pretty rare, especially up here in the United States, because if you actually look at it, it most likely hit here. What you think? They'd get more, but and it's actually at the top, which this isn't 100% accurate, considering that the Earth is tilted sideways. That makes the seasons, but whatever. Us it being up here, and think about it, Florida is known for its typically hot climate, but the equator's like down here, so you can see how much that changes. Anyways, let's see. Galaxy collision. Now this is awesome. So about 4 billion years from now, our Milky Way galaxy will collide with the nearby Andromeda galaxy. This collision, as a result of the mutual gravitational attraction between the stars, planets, and other matter, will make up both galaxies, will produce a single merged galaxy. It is unlikely that any stars in the galaxies will actually collide, although some stars will likely be ejected from the combined galaxy during this merge. So as you can see here, so here's us here, the Milky Way, and this is Andromeda. And look, it's just a massive collision. And if you think about this, look down here. All those years going by, that is a very long time. And this definitely won't be happening in any of our lifetimes. But it is still a very cool fact to think about there. So this is, I think, another thing. It's a simulation. Jupiter fly around the sun, collapsing moons. This one is, in this simulation, 21 copies of Earth's moons are placed near each other in space. This material gravity between the moons pulls each other together, resulting in a catastrophic collision. So, pretty neat here. Which, as you can see, so this one is a lot bigger now. It's because they kind of clash together and make that, which actually there is a theory that does say that the moon might have actually come from Earth as the result of that so-and-so asteroid that killed the dinosaurs, it could have broken off the Earth and pushed, I guess, out to be in the orbit. But that is not 100% true. So yeah, this one is pretty neat. So it looks like it's a bunch of moons surrounding the Earth, and as you can see, oh, that's nice. I like that. That's cool. Actually, not for the Earth. Okay. Let's see. Alright, so here's the Earth and the Moon, very close together, and as you can see, they're very close together. And then the Earth's orbit is actually, their Earth's gravity is actually so strong that it's ripping it apart. This is what happens when objects from space come down. Most of the time, people, some people are like, oh no, something's gonna come and fall from the sky, all this trash that we have in the sky, but that is not true. This trash and all this stuff is just so small, but by the time it enters Earth's atmosphere, it will be completely burned up and won't even have any chance of hitting you. It's not to say that it hasn't happened before. It definitely has. A big enough piece could hit you, and even if it was a big enough piece, it would most likely be small enough that it wouldn't hit you or harm you in any way. And even if it was managed to be big enough, it has to go all the way through the atmosphere and completely completely get all the way from the atmosphere and hit 1 out of what the entire Earth. This is a lot of space, but in the grand scheme of things, not really not. So let's read this off. The side of the moon that is closest to the Earth experiences a larger gravitational attraction than the side farthest from the Earth. The closer the moon is to the Earth, the greater difference becomes between the two forces. The moon stretches along the direction towards the Earth due to its tidal force. Objects that orbit too close to the Earth inside its rock limit can be torn apart by tidal forces. In the simulation, if the moon orbits within the Earth's large limit, it begins to break apart within minutes, sending fragments flying into the Earth. So it would be very devastating for us. So don't want that to happen. Earth and early moon. So this is another one. It looks like all these fragments here. It broke off. It looks like they coming down onto Earth. I don't know which one's the moon. I think after enough of these, so you can see it after hours and hours. Well, it looks like the Earth just got let's. Okay, so it looks like they all closed in on Earth, completely annihilated it. Okay, it looks like it eventually came to that. And then okay, so it looks like nothing's gonna happen left, maybe. Should gain oceans and stuff, but I don't know. This doesn't look like a very rich Earth, but okay. It says seconds, I don't know. Black hole and the sun. In this simulation, the sun orbits a black hole that is 10,000 times more massive than itself. The sun's orbit is very eccentric, and takes within the black hole's Rock's limit, as at this point the tidal forces of the sun become strong enough to rip it apart of the material that is to be the sun, and continues to orbit the black hole while the rest is thrown into space. This entire system, the black hole and the sun's eccentric orbit, would fit inside the orbit of Mercury in our own solar system. So it's pretty cool. You can see all this being thrown around, and there's the black hole, which black holes are cool if you think about them. So that's let's see what else we got here. We have a bunch of different Earths at different. So as you can see, Earth at 1,000 degrees starts going red. At 2,500 degrees, it gets even redder, and then almost it looks like the sun at 5,000 degrees, and at 10,000 degrees it starts to get blue. 20,000, it looks like it's growing almost. 5,000, and then as you can see, it just Alright, so this is cool, looks like. So it's, as you can see, in the simulation, the two Earths orbit each other at the distance half their radius. As you can see, they're starting to rip apart here, because they're rocks, let me remember. The side of the Earth that is closest to the other Earths experience a larger gravitational attraction than the side farthest from the Earth. Then you can see this one it's kind of like a bottle. It's almost growing that way, but because the Earths are so close to each other, the differences between these forces is large, and the Earth stretches towards these forces. Because the Earths are so close together each other, the difference between their forces is large, meaning that the Earth stretches towards the other due to its tidal force, which Earth is heated by tidal forces, and one is eventually ripped apart, these fragments continuing to orbit and collide with other Earths. The other Earths, so as you can see, these are 100,000 kilometers apart, so travels a great distance, but that is pretty cool there. And then we have all sorts of simulations. We have a few grids here. Saturn and its moons. This is kind of oldish. The newer stuff is up here with Parker Solar for closest approach and stuff. So, yeah, that is pretty cool. Let's see some explosions. Physics. We'll go with some collisions. Earth and Earth here, so that's a collision between the two Earths. In this simulation, Earth crashes directly into the twin Earth, producing a spray of massive fragments and superheating the surface of the surviving Earth. So pretty cool. You can see all these fragments here, and this is the surviving Earth itself. Pretty neat. Jupiter and Earth, already know who's gonna win this one, but as you can see how big that was. That's almost that did a great lot of damage, but the initial impact was almost the size of the red spot, which looks like on the back. But normally, I guess, giant Jupiter orbits far from the Earth beyond the asteroid belt, but in this simulation, however, the Earth crashes directly into Jupiter. The Earth is destroyed in the collision, and its fragments are swallowed up by Jupiter, which heats to over 1,500 degrees Celsius from the energy of the collision. So, pretty neat there. Earth and Moon 5 times, so 5 Earth, 5 moons versus 1 Earth, and as you can see, it completely knocks Earth off track. Looks like, and yeah, normally there stays within a circular orbit around the Earth, but in this simulation, however, 5 moons in a row crash into the Earth, superheating its surface and making it begin to rotate. So, pretty neat there. So let's see some explosions. Supernova, the sun, and alright. So here's supernova. So this is very slow, by the way. But as you can see, which this isn't 100 representative, because the Earth will actually be completely gone by the time this happens. Because, well, it wouldn't necessarily be gone, but we would be dead before this happens, because the heat from the sun, as it keeps growing, would eventually go all. So, our sun will never experience a supernova due to its low mass. It will eventually evolve into a red giant and then a white dwarf. However, in this simulation, a supernova is triggered in the sun, sending an expanding cloud of gas towards outwards in the solar system. This cloud reaches the Earth within an hour. The supernova within 6 hours. It will reach the orbit of Jupiter within 24 hours. The cloud is expanding into the outer reaches of our solar system. So, pretty neat there. Earth exploding in real time. As you can see, they're slowly in. Looks like we just completely seems to be growing. It's just a break apart. Let's see this. I'm expecting just an Earth fragment. Speed this up. Cool. Alright, so in this simulation, the moon circles the Earth in its normal orbit. 2 seconds into the simulation, the Earth explodes, sending fragments in all directions in real time. A simulation time step of 1 second per second. It takes over 12 hours for these fragments to reach the moon's orbit. The moon's surface is heated, and as it collides with some of the fragments without Earth's gravity to maintain its orbit, the moon flies off in a straight line. So as you can see, there it goes, and you can see all the fragments going away. So we're gonna go back over here to physics. These ones look pretty cool. So it looks like the Earth are locked in place, and as you can see, it just completely tears apart the gravity. It's a baby Earth. So yeah, in the simulation, 2 Earths are placed next to each other at a distance of half the radius held in place. This side of each Earth is closest to the closest to the other Earth and experience a larger gravitational attraction than the farther side on the other Earth. Because of the Earths are so close to each other, the difference between these forces is large, and each Earth stretches towards each other due to its tidal force. Each Earth is heated by tidal forces, and one is eventually ripped apart, leaving its fragments orbit and collide with their other Earths. So pretty cool there. And yeah, we'll do, I don't know, a couple more singles. The human scale, human-sized objects, two-sided die. Alright, so here's the Party Solo Pro. It is so here is Party Solo Pro, and it's about the size of a car there. Tesla Roadster. Slowly we get bigger with the Juno spacecraft. And then there's that rival spacecraft. What? Okay, and then I'm assuming is there anything else? No, looks like there's not. So that's pretty neat there. Some human size object. This is 2 dice in space. Their mutual gravitational attraction pulls them together. The dice and the other human size merge into a larger object when they collide in the future be much more realistic. Okay, cool. But actually, if you were to put 2, let's say baseball dice in a 100% vacuum, like 100%, which has never been done before, they would actually still collide because every object has their own gravitational force. So yeah, that's pretty cool. I'm gonna leave that here for today. I hope you guys enjoyed this video, and if you did, please leave a like, comment, subscribe. Yeah, and I guess I'll see you guys in the next video. Goodbye.